Hey guys, so today we are going to talk about exponential growth and exponential decay. So right away you should be noticing the equation y equals a times b to the x power. Y equals a times b to the x power. Okay, within this equation, a is the initial amount of whatever it is that you have. Okay, so something that grows exponentially could be your bank account. So that would be your initial amount in your bank account. All right. B is your growth or decay factor. So B decides, okay, is the amount of money in my bank account going to grow, or is it going to decay? Is it going to go down? Okay, this is a lot. I shouldn't say bank accounts. I should say stocks. Okay, so A is the initial amount you invest in your stock. B could be the growth or decay factor. Sorry. The growth or decay factor that it is either A, growing by, increasing by, or B, decaying by. Okay, so if you look at the graph, okay, now this part of the graph here, okay, this is showing exponential growth. This is when your B is greater than 1, okay? Now this here, okay, this is when this is neither exponential growth or exponential decay. This is just when your A is negative, okay? Here, this graph is showing exponential decay. Okay, so if you were to invest $1 million in a stock and then it plummets, you would see a graph looking something like this. This is when your B is between 0 and 1, so it's generally represented as a fraction. All right, so and again, here is when your A is negative, but you'll never be investing a negative amount, so this is not considered growth nor decay. Now, moving on, determining whether a table represents a linear or an exponential function. Okay, we've done this before, where if you're adding or subtracting consistently by a number, that means it's a linear function. Well, if you're multiplying or dividing consistently by a number, that's exponential. Okay, so from 8 to 4, right? From 8 to 4, okay, we've divided by 2, okay, but I'm going to represent that as multiplying by 1/2 because that's the same as dividing by 2, but your exponential growth or decay factor is always what you multiply by. So I'm going to represent it as multiplying by 1/2, right? Multiply by 1/2 and you go from 4 to 2, multiply by 1/2 and you go from 2 to 1. So in this case, your exponential growth factor, your B would be equal to 1/2. And this is going to be exponential. Okay, I know I said growth before, but when you're multiplying by a fraction, it's exponential decay. All right. Number 2, okay, I'm looking at this and I'm seeing a pattern of from 3 to 7 plus 4, from 7 to 11 plus 4, from 11 to 15 plus 4, okay? When you're adding or subtracting, that represents a linear function. Since we're adding 4 each time, it's going to be a positive linear function, okay? Because we are increasing, okay? Looking at number 3, I'm noticing a pattern of subtracting 3 each time. Okay, so this is going to be considered a negative linear function because we're consistently subtracting, so we're going down from left to right by 3. all right? And the last part, okay, 0.125, okay, I'm seeing a multiplication of 4 here. And I didn't notice that from 0.125 to 0.5. I actually noticed it from 2 to 8 first, that we're multiplying by 4. And then I was able to imply that from 0.5 to 2, we're multiplying by 4 as well, okay? So this is going to be considered exponential growth. Because we're multiplying by 4, we're increasing, and our growth factor is going to be 4. Okay? Now, we need to evaluate the function for the given value of x. All right? So, if y is equal to 3 to the x power and x is 5, that's y is equal to 3 to the 5th power. Okay? 3 to the 5th power, okay, when I plug that into my calculator, you guys should all have calculators, 3 to the 5th power comes out to be equal to 243. Okay? Number 6. Y is equal to 1/4 to the x power. Well, if x is 3, okay, we can separate this into 1 to the 3rd power over 4 to the 3rd power. 1 to the 3rd power is 1. 4 to the 3rd power is 64. All right. And then we have y is equal to 3 times 4 to the x power when x is 4. So, what I'm going to evaluate first is exponents. 3 times 4 to the 4th power gives me 256. Okay, so now I want to multiply that number by 3, and I get y is equal to 768. Okay? All right, so on to page number 2. Okay, a lot of graphing on page number 2. When you're graphing an exponential function, okay, you really should make a table. Okay, that's my favorite way to graph an exponential function, is to make that table. I usually go -2, -1, 0, 1, 2. Okay, so that's what we're going to try here. You might need extra paper, I'm not sure, but we're going to make a table. X, Y. And we're going to plug in for x -2, -1, 0, 1, and 2. Okay, now I strongly suggest you get an extra piece of paper and that you do each problem out. So if you do -2 to the -2 power, right, that's going to become -1/2 squared, right? That negative symbol, if you remember from the previous chapter, that negative symbol makes us use the reciprocal. Okay, so we now have -1/2 squared, and 1 squared is 1, and 2 squared is 4. So at -2, y is -1/4. Okay, now we do -2 to the -1 power. Again, the negative flips it, right? And then we have it to the first power, so that comes out as just being -1/2. Okay, so at -1, y is -1/2. Okay, -2 to the 0 power, anything to the 0 power we know is 1, with that negative out in front. Okay, so that's going to be -1. -2 to the first power, anything to the first power is itself, so that's going to be -2. And -2 squared, well, 2 squared is 4 with a negative out in front, right? -4. Okay, now we have to graph these. So I am going to switch to a black pen to create my X and Y axes. Okay. There we go. All right, and then I'm going to switch back to the red pen to graph it. So, -2, -1/4, that's about here. -1, -1/2. 0, -1. 1, -2. And 2, -4. So, we have a graph of a function that shows neither exponential growth or decay, okay? And it says compare the graph to the graph of the parent function. The parent function is y is equal to b to the x power. So that would look, the parent function would look something like 0, 1, something like this. Okay, the parent function is something similar to this. Okay, now comparing it to the graph of the parent function, okay, we are ending up with a reflection over the y-axis. Okay, and then it says to describe the domain and the range of the function. So the domain in this case, okay, you can put pretty much anything in for x. So that's going to be all real. Okay, but the range is a little different. Looking at our red graph, because that's our function, the red graph. So looking at the red graph, our range, well, y does not, our graph doesn't cross the y-axis, so y has to be less than 0. It also never touches 0, if you've noticed that as well. Okay, so y is less than 0. All right. So again, when you're graphing an exponential function, you really want to make that table. So I'm going to make that xy table. And start with -2 and -1 and 0, 1, 2. Okay. So 2 times 1/4 to the -2 power, that flips the 1/4 to a 4/1 and squares it. So 4 squared is 16. 2 times 16 is 32. Okay? 2 times 1/4 to the -1 power is equal to 2 times 4. 2 times 4 is 8. Okay, so we have 32. We have 8. 2 times 1/4 to the 0 power is equal to 2 times 1, which is just 2. 2 times 1/4 to the first power is equal to 2/1 times 1/4, which comes to 2/4, which is equal to 1/2. Oops. Okay, and then we have 2 times 1/4 squared, which is equal to 2 times 1/16, which is equal to 2/16, which reduces to 1/8. That's going to be difficult to graph, but we'll estimate it. Not a problem, because we can estimate these things. So I draw my x-axis. I draw my y-axis. Okay, and then I go back to the pink to graph it. -2, 32 is not on my graph, but -1, we're going to go by 2, 4, 6, 8 is. Okay, -1, 8. 0, +2. Okay, oh, this is 1/8, sorry. Okay, positive 1, positive 1/2. That's about there. And then the last is positive 2, 1/8. Okay, again, we are approaching 0, but never crossing that line. That's called an asymptote. Okay. It says describe this compared to the parent graph. Well, with that 2 in front, okay, with that 2 in front, I am seeing a vertical stretch by 2. Okay, and then the next part asks for the domain, okay, which we very clearly were able to put anything in for x, so that's going to be all real. But we also have to consider the range. Notice that the graph approaches the y-axis but never crosses it, so y has to be greater than 0. Okay, it never crosses that y-axis, so I don't want to put or equal to. It's just got to be greater than 0. Okay? Now, here comes a part that's a little bit different. There's a -2 after my exponential function. Okay, so what do you think is going to happen when there's a -2 next to it? That's right, it's going to be moved down 2. So let's pick a new color here, maybe a purple. Make our x and y table, -2, -1, 0, 1, and 2. Okay, and we're just going to plug it in like we have been. 4 to the -2 power minus 2. Okay, that's going to be equal to 1/4 squared minus 2. Okay, 1/4 squared is going to be 1/16 minus 2, which could get kind of ugly. 1/16 minus, we're going to make 2 32/16. This way we have 16 in the denominator. This is going to be 32/16. That's going to be equal to -31/16, which is 1 15/16. Okay, so that's 1 15/16. All right, so that is very close to that negative. Oh yeah, it's -1 15/16. That's very close to -2. Okay, let's try the next one. So 4 to the -1 power minus 2. So that's going to be 1/4 minus 2. So I'm going to do 1/4 minus 8/4. Okay, and that's going to be equal to -7/4, which is equal to -1 3/4. Okay, so next comes 0. 4 to the 0 power minus 2. 4 to the 0 power is 1, minus 2 is -1. 4 to the first power minus 2 is 4 minus 2, which is 2. And 4 squared minus 2 is 16 minus 2, which is 14. So, I need to graph this. Oh, wait, fill this in here. I have to graph this. All right. I'm going to put my x-axis somewhere here. Okay. Nope. Okay. And I'm going to put my y-axis down the middle as best as I can. All right. So when we fill in our points, +2, +2, 4, 6, 8, 10, 12, 14 is up here. +2, +14. +1, +2 is right about here. 0, -1 is here. Okay, and then -1, -1 3/4 is about here. -2, -1 and 15/16 is there. So notice now how our domain and range change. Okay, our graph moved down 2. So my domain actually stayed the same. I can still put any value I want in for x, but my range is now y is greater than 2. Okay, -2, sorry, because we moved the entire graph down 2 spots. Okay, so here's another tricky one. All right, let's build our graph. Okay, we're going to make an x and a y table. Okay, I am going to plug in -2, -1, 0, 1, and 2, and we'll evaluate at those points. So 4 times 1/2 to the -2 power is equal to 4 times 2 squared, which is 4 times 4, which is 16. Okay, the negative flips that 1/2, so it becomes 2, and then we square it to get 4. Okay, 4 times 1/2 to the -1 power, oh, never mind, erase this, I forgot an integral part of the function. My apologies. I forgot the +1 here. So we have to do 4 times 1/2 to the -2 plus 1. So that's 4 times 1/2 to the -1 power. The -1 flips my fraction to be 2, and 4 times 2 is equal to 8. That's much better. 4 times 1/2 to the -1 plus 1 power is equal to 4 times 1/2 to the 0, which is 4 times 1, which gives me 4. Okay, 4 times 1/2 to the 0 power is equal to 0 plus 1, my bad, okay, is equal to 4 times 1/2 to the first, and 4 times 1/2 is actually equal to 2. Okay, 4 times 1/2 to the 1 plus 1 power is equal to 4 times 1/2 squared, which is equal to 4 times 1/4, which is equal to 1. And the last one, 4 times 1/2 to the 1 plus 2 power is equal to 4 times 1/2 cubed, which is equal to 4 times 1/8, which is equal to 4/8, which is 1/2. Okay, so we make our grids. Okay, grid lines are made. Okay, and we graph our function. So we have, we have -2, positive 2, 4, 6, 8. We have -1, positive 4. We have 0, positive 2, 1, 1, and 2, 1/2. Okay, so our function now looks like this. Okay, from the parent function, we have moved to the left 1, and there has been a vertical stretch by 4. Okay, our domain and range, however, have not changed. Our domain, we can still put anything in for x. Our range, y still is greater than 0. It will never pass 0. All right, so that is how to graph an exponential function in a nutshell. When in doubt, make a table. Okay, now parts 12 and 13, they want us to write an exponential function represented by the table or the graph. Okay, so remember the parts of an exponential function are a, the initial amount, and b, growth or decay factor. And the equation is always y equals ab to the x power. So in this case, okay, we are multiplying by 6 each time. Okay, so our growth factor here is 6. Our initial amount is where x is 0, so that's at 3. So our equation should read y is equal to 3 times 6 to the x power. Okay? Looking at this equation here for number 13, okay, I'm immediately shown that my initial amount is negative 0.5, okay, and then my growth factor, okay, from here to here, from this point to this point, I'm dividing by 2. I'm dividing by 2 to get to here, and dividing by 2. So I believe that my growth factor is dividing by 2, which is multiplying by 1/2. So my equation would be y is equal to negative 0.5 times 1/2 to the x power. Okay? And in a nutshell, that is graphing exponential functions and finding exponential functions, exponential growth and decay. Okay? All right, on to 6.4.